Redox reactions. This is the sixth topic for the 11th science. In this lecture, we are to see about the balancing of redox reactions. There are two methods are used to balance the chemical equations for redox processes. The first method is oxidation number method and second half reaction method or ion electron method. These are the two methods are used to do balancing of the redox reactions. Out of these two, the first method is the oxidation number method is discussed in this lecture. Also, we are to find out the values of the chemical reaction by using the oxidation number method to determine the balancing chemical equation. The oxidation number method is illustrated in the following steps. There are 5 different steps are involved. The first step is write the unbalanced chemical equation for redox reaction. Balance the equation for all atoms in the reactions except hydrogen and oxygen. Identify the atoms which undergo change in oxidation number and by how much draw the bracket to connect atoms of the element that changes the oxidation number. Means in these steps we can write the unbalanced chemical equation and balance this equation by the except hydrogen and oxygen, and also there is an identification of the atoms which undergoes oxidation or reductions. Second step contains show an increase in oxidation number per atom of the oxidized species and hence the net increase in the oxidation number. Similarly, show a decrease in oxidation number per atom of the reduced species and the net decrease in the oxidation number. Means determines the factors which will make the total increase and decrease equal. Insert the coefficients into the equations. Means there is oxidation number is increases or decreases for some species are first determined and also determines there is a factors which will make the total increase and decrease of that oxidation states. Third rule, balance the oxygen atoms by adding H2 to the side containing a less number of oxygen atoms. To the side of the less number of oxygen atom and 1 H2O is added for 1 oxygen atom. Balance the hydrogen atoms by adding H plus ions to the side having less number of hydrogen atoms. Means the hydrogen atoms are added exactly opposite to that of these water molecules. The next is a last step 4. If the reaction occurs in the basic medium, then add OH minus ions equals to the number of H plus ions added in the step 3. On both the sides equation, the H plus and OH minus ions on the same sides of the reactions are combined to give the water molecules. Means in this third step, by adding H2 to balance the oxygen atoms. In this case, add the OH minus ions to equals to the number of the H plus ions. There are addition of this OH minus ions on both the sides, and also there is a H plus and OH minus ions are present on the same side. Then they can form water molecule. And last step, check the equation with respect to both the number of atoms of each element and the charges. Then it is a balanced equation. Last step contains there is a check the number of oxygen atoms, hydrogen atoms, their charges are balanced or not. If all the species are balanced, then this reaction is a chemically balanced equation. Note here, for the acidic medium, step 4 is omitted because there is a in case of the basic medium, then the OH minus are added to equals to the number of hydrogen atoms. Hydrogen H plus ions. Okay, if the basic medium are present, then fourth step is included. If the acidic mediums are present, then fourth step is excluded. The next is a problem. First, numerical in our textbooks. Using the oxidation number method, write the net ionic equation for the reaction of potassium permanganate KMnO4 with ferrous sulfate FeSO4. The given reaction is MnO4 minus aqueous plus Fe2 plus aqueous. It gives Mn2 plus aqueous plus Fe3 plus aqueous. Fe2 plus converted into the Fe3 plus and MnO4 minus there is a plus 7 is converted into the plus 2. For this examples, there is a solution. First, step 1. The skeletal ionic equation is. This equation is right as it is in case of the skeletal ionic equation. The step 2 contains assign the oxidation number. Assign to the oxidation number of manganese and iron and calculate increase and decrease in the oxidation numbers and make them equals. Then in this equation, manganese shows plus 7 oxidation state, oxygen minus 2, iron plus 2, and these oxidation states are changes in case of the product is plus 2 in case of manganese and plus 3 in case of iron. Therefore, the increase in oxidation number Fe2 plus to the Fe3 plus, there is increase per atom is a plus 1 oxidation state, and decrease in oxidation number there is a plus 7 and there is a plus 2. Therefore, plus 7 to plus 2 decrease per atom oxidation state is a 5. To make the net increase and decrease in equals to the must be take 5 atoms of the Fe2 plus. Means there is a cross multiplication. This decrease per atom multiply this number to the first equation, and there is an increase in per atom of oxidation state. This term multiplied by the second equation. Then it gives there is a MnO4 minus aqueous plus 5 Fe2 plus aqueous. It gives Mn2 plus aqueous plus 5 Fe2 plus aqueous. Means this first equation multiplied by 5 and second equation multiplied by 1. This is a cross multiplication. Then steps 3. There is a balance the oxygen atom by adding 4H2O to the right hand side, because there is a oxygen atoms present in the MnO4. There are 4 oxygen atoms, hence this balance this oxygen atom on the right side by adding the 4 H2O molecules. And the step 4, The medium is acidic. To make the chain charges and hydrogen atoms on the two sides equal, add 8 H plus ions on the left hand side because these are the 4 get 2. They are balanced by adding the 4 H plus on this left side. The equation is obtained this. In fifth step, check the two sides of the balanced charges and atoms. This equation check there is a two side balancing the charges as well as the atoms, and the net ionic equation obtained in the step 4 is a balanced chemical equation. Write this equation once again for the balanced chemical equation. MnO4 minus aqueous plus 5 Fe2 plus aqueous plus 8H plus aqueous. It gives Mn2 plus aqueous plus 5 Fe3 plus aqueous plus 4H2O. And this is a balanced chemical equation. Similarly, solve another example present in our textbook. This is a balance the following reaction by oxidation number method. In this example, CuO, cupric oxide, reacted with NH3 ammonia, it forms copper, nitrogen gas and water molecule. Balance this equation by using oxidation number method. Take for this homework and solve very easily. Easy steps are involved in the example. Solve carefully and study these reactions, how to balance the chemical equations by oxidation number methods. The next most important point is the redox reaction and electrode potentials. The redox reactions means already explained this point. Oxidation and reduction reactions are occur simultaneously in the reaction. Then these reactions are called as a redox reaction. And the electrode potential. Electrode potential means the potential difference between the two electrodes or the potential difference between the two half cells is called as the electrode potentials. In this redox reaction and electrode potential, another point is involved is the Daniell cell. And this Daniell cell contains the steps involved in the Daniell cell. The first, the Daniell cell can be conventionally represented as Zn solid plus Cu2 plus Zn solid plus Cu2 plus aqueous. It gives Zn2 plus aqueous plus Cu. In Daniell cell, the electrons are flows from the zinc electrode to copper electrode. Electrons are flows from zinc electrode to the copper electrode through an external circuit. While the metal ions form one half cell to the other through the salt bridge. While the metal ions forms one half cell to the other through the salt bridge. Here the current flows from the copper electrode to the zinc electrode, that is cathode to anode via a external circuit. Here the current is flows from the zinc electrode to the copper electrode. And the Daniell cell is reversible cell, while a voltaic cell may be reversible or irreversible. These are the steps involved in the Daniell cell The figure as shown in this slide. This is a zinc metal electrode, acts as an anode. This is a copper metal strip, acts as a cathode. This is a zinc salt solution and this is the copper salt solution. These two half cells are connected by using the salt bridge. This is a U-shaped glass tube is a salt bridge. This anode is externally connected to the voltmeter and this is again connected to the cathode by the external circuit. In this case, the oxidation occurs. This is a Zn2 plus 2 electrons. Oxidation occurs on this anode and therefore electrons are flows from this anode to the cathode in external circuits. Therefore, Zn2 plus ions present in this solution gain these two electrons coming from this anode and form there is a copper solid. In these reactions, the zinc metal rod is dissolved in the solution and forms there is a mud at the bottom side of the beaker, and this rod is dissolved in that solution. Their size is reduced. In case of the copper sulfate solutions of the copper ions are present, they deposited on the surface of this copper strip. Therefore, size of the strip is increases in Daniell cell due to the deposition of the copper ions present in that solutions. This is a Daniell cell. Next is the cell reactions. The cell reaction zinc ions present in a zinc sulfate solution. Zn2 plus 2 electrons, copper, Cu2 plus 2 electrons into Cu. The net cell reaction is Zn plus Cu2 plus is equal to the Zn2 plus Cu2 plus. Zn2 plus Cu. Okay. And the cell is represented as Zn oblique Zn2 plus, salt bridge, Cu2 plus and Cu. And this representation is the Daniell cell. This is the cell representation and cell reactions are zinc lose their 2 electrons for Zn2 plus, copper gain the 2 electrons for the Cu as a solid. And these are the cell reactions occurs in the Daniell cell. Next part is the salt bridge. The salt bridge, it maintains the electrical neutrality in two compartments by allowing movement of anions towards the anodic compartment, by allowing the movement of the ions towards the anodic compartment and cations towards the cathodic compartments. It maintains the only electrical neutrality. Second point is it is glass tube having the potassium chloride and ammonium nitrate in a gelatin forms. The gelatin allows the ionic movement but prevents any kind of mixing. This gelatin also contains there is a agar-agar gel. The gelatin allows the ionic movement but prevents any kinds of the mixing. In the case of the potassium chloride or ammonium nitrate, the ionic mobilities of the cations and anions are the same. Ionic mobilities for the cations and anions are the same, and this is the salt bridge. The next is the functions of the salt bridge. A salt bridge acts as an electrical contact between the two half cells. It prevents mechanical flow of the solution, but it provides the free path for the migration of the ions to maintain the electrical current through the electrolyte solution. It prevents the accumulation of the charges. A salt bridge helps in maintaining the charge balance in the two half cells. and a salt bridge minimizes or eliminates the liquid junction potential. These are the four important functions are carried out by this salt bridge. Next is the electrode potential. This electrode potential means the potential difference of two half cells or the electrode is called electrode potential. Standard electrode potential definition. Under standard conditions, the standard electrode potential occurs in the electrochemical cell. Say that temperature is 298 Kelvin, pressure 1 atmospheric pressure, concentration is 1 molar, and the symbol is E0 cell represents the standard electrode potential of the cell. Means all these conditions are present or termed as a standard conditions. In the standard conditions, if the large negative values of E0 means the redox couple is the stronger reducing agent. There is a large negative values, then this is redox couple is the stronger reducing agent. On the other hand, more positive values of the E0 means this is the redox couple is a stronger oxidizing agent. This E0 referred as the standard reduction potential. Reduction potential is according to the IUPAC nomenclature. It is represented in terms of the reduction potentials. Hence, they are termed as a standard reduction potentials. If these values are the negative, they are the reducing agent, and the E0 values are more positive, then they are acts as the oxidizing agents. The alkali metals have the high negative values of E0, which means that they are strong reducing agent. They remove electrons and forms their cations. On the other hand, the fluorine or the halogen family, these elements having the high positive values of E0 and thus greater tendency to gain the electrons and is therefore they are very strong oxidizing agents. And this is depending upon the standard electrode potential and another one arrangement of the electrodes in their decreasing order of the standard reduction potential gives the electrochemical series. And this electrochemical series is as shown in this table. This is a fluorine attracts 2 electrons for the 2F minus and this potential electrode potential is 2.87. This is the positive value and from fluorine to bottom side the lithium the metallic character goes on increasing and therefore in case of the lithium minus 3.05 this large negative value indicates this is a reducing agent and this positive value 2.87 in case of the fluorine they are the stronger oxidizing agent. According to this table the reducing agent increases from top to bottom and from bottom to top oxidizing character goes on increases. This is the last point of the standard electrode potential of the some redox couples. This is a arrangement of the electrodes in their decreasing order of the standard reduction potential. This series is also called as a electrochemical series. Here topic is completed. Thank you.